All right, let's evaluate the following indefinite integrals. If you notice, we have three examples that look somewhat similar. Let's look at the first example. So it's the integral of 1 over x dx. We know the antiderivative rule for this, or at least we know whose derivative is 1 over x. The function is the natural log of x, or the natural log of the absolute value of x. That has a derivative of 1 over x. So when we see the 1 over x, we have to know automatically that this has an actual answer. It's the natural log of absolute value of x. Don't forget the plus c. Why plus c? Because it's an indefinite integral, so we make sure to put the plus c. Now, let's say you didn't remember that this was natural log of x, and you decided to rewrite this as x to the negative 1 dx. And then you try to do your add 1 to the power, divide by the new power antiderivative rule. Well, let's try it. X to the negative 1 plus 1, divide by negative 1 plus 1. Well, that would be x to the 0, divide by 0, and you cannot do that. Therefore, you have to remember the antiderivative of 1 over x is the natural log of absolute value of x. All right, so using this fact, let's try the second indefinite integral. So we have the integral of the natural log of x divided by x dx. Well, in this case, I know I have to use a u-substitution. So I need to pick a u, and I'll have to pick the du, and I have to make sure that my du is actually inside my integral to make my life easier. So let's just mess up for a moment. Let me say I pick u to be x. Then du is just 1 times dx. And yes, 1 is technically here, and dx is there, but it doesn't help me with the ln of x. Therefore, that should let me know I picked the wrong u. So let me pick another u. Let me pick u to be ln of x. Then du, the derivative of u is du. So what's the derivative on the right side? What's the derivative of ln of x? Well, it's 1 over x dx. Let me rewrite my integral. So let me separate this ratio. So I'll have ln of x times 1 over x dx. So here's my u, and here's my du. So I'm good to go. So I'll go ahead and put equals. So after I get u and du, I'm going to play the substitution game. So instead of ln of x, I'll put the entire u times, instead of 1 over x dx, I'll just put du. Now I can do the antiderivative rules, which is add 1 to the power, divide by the new power. So this becomes u to the second power, divide by 2, plus c, because it's an indefinite integral. Then the last thing I need to do is replace the u. So instead of a u, it should be ln of x. So this becomes ln of x, whole thing squared, divide by 2, plus c. And again, we can check our answer by just taking the derivative, and we should get this expression back. You check this answer by taking the derivative, see if you get this expression back. All right, let's try the third one. So the third one kind of looks familiar to the second one and the first one, just a little different. Let's see how different it really is. So I know I need a u and a du, but this time I see the 1 over x and I see a 1 over ln of x. So maybe I need to rewrite this first. So I'll rewrite it as 1 over ln of x times 1 over x times dx off to the side. All right, so if I said, well, let my u be 1 over x, I know my du isn't going to help with ln of x at all. If I say let my u be 1 over ln of x, then I'm going to have a problem finding du. So instead of letting u be 1 over ln of x, let u just be ln of x. U is just ln of x. So then if I find the du, 1 over x dx, that's over here. There's the ln of x. So now I can replace or substitute everything, and I end up with 1 over u times du. Notice the difference between the second and third examples. When we substituted the u, we ended up with u times du. When we do it up here, we end up with 1 over u times du. And that's because the ln of x was in the denominator, and this ln of x is in the numerator. All right, so what does this mean? Well, the antiderivative of 1 over u, well, we know that to be the natural log of the absolute value of u, plus c, of course. Well, now to finish it, we have to replace the u. Well, what was u? Ln of x. So watch this. This will become natural log of the absolute value of the natural log of x plus c. And of course, we can check this by taking the derivative, and we should get back this expression. So in this video, we looked at u-substitution, in particular, using the natural log of x. Notice the difference between the second and third examples. All right, have a good day.